In this video, we're going to take a look at the sum of an arithmetic series. So far in class, we've taken a look at sequences, both arithmetic and geometric. And the first word we need to define is series here. And you just need to know that a series is simply the sum of a sequence. So if we take all the terms in a sequence up to a given number of terms, what do they all add up to? And we've already taken a look at an example of this in class. Find the sum of all these numbers, 1 up to 100. And what we saw in class was that one way you could do it is by simply adding them in order, but there's a more elegant way to do it if you start taking them in pairs. So what we looked at is, for example, if you take 1 plus 100, you get 101. And if you take 2 plus 99, you also get 101. Get the same thing if you take 3 plus 98, 101, and so on and so forth. So there is a way to do these guys. And the way that we find the sum of these numbers is we just consider how many 101s there are. Well, we know that there are 50 pairs of 101, so it's okay to just take 101 times 50 and you get 5,050. So we want to use this technique now to try to find more exotic sums. So here's our first example. Let's say we want to find the sum of something like this, 6 plus 10 plus 14, all the way up to 30. We see it's arithmetic. Its common difference is 4. It's an add 4 pattern. And we can use the same idea here. Instead of just adding them in order, we can add them in pairs. 6 plus 30 is 36. 10 plus 26, that's 36. 14 plus 22, that's 36. And I have one number left over. But I get a whole bunch of 36s, and the question is, how many 36s do I have? Well, I end up with 3 36s, plus I have this extra 18 left over. Or another way to think of it is, I have 3.5 36s. Because keep in mind that 18 is half of 36. So I can do 3.5 times 36, and I get 126. So this series adds up to 126. So we're going to use this idea of pairing them up and finding out how many pairs we have in order to find the sum of a series. So to find the sum of an arithmetic series, here are the steps that we need to do. So really the idea is that we're going to take the first term in the list and we're going to add it to the last term in the list. And what we need to think about is how many of those pairs will there be? Well, the number of pairs there will be is half the number of terms. So if there are 50 pairs in a list, if there are 50 terms in a list, there'll be 25 pairs. If there's 100 terms in a list, there'll be 50 pairs. Another way to say this symbolically means that if we want the sum of the n terms in a list, so this time we're using the letter S for sum, we take the first term plus the last term, and we multiply it by half the number of terms. So we can do it by using a written description, or we can use a formula, either way. So let's use this to do a couple examples here. So here's our example. So we want to find the sum of the first 50 terms of this series, 2, 5, 8, 11, and so forth. And we can see here the common difference is 3. We are adding 3 here. Well, let's think about the formula and all the things we need. We would need the first term, we would need to know what the last term is, and we need the number of terms. And think about which of these things do I know? Well, I know the first term. The first term is 2. The last term I don't know because it just keeps on going on for 50 terms, but I know that there are 50 terms. So already 3 of the 4 things that 2 of the 3 things here I already have. It's just the last term. Well, the last term is really just the 50th term. What is that term in the list? Well, this is the same stuff we've been doing in class with sequences. I want to find the 50th term. And we know that the 50th term means we take the first term, which is 2, and we add the common difference here 49 times. So if I want the 50th term, I use the common difference 49 times. Put that in your calculator and you'll find that that's 149. So this is the 50th term. So we have everything we need. The first term, the last term, and the number of terms. We have everything we need to now figure out the formula here. Okay? So if I want the sum, again, I'm going to take the first term plus the last term, and I'm going to multiply it by half of the number of terms. And I have everything I need. The first term here is just 2. The last term is the 50th term. That's 149. And I'm going to multiply it by half of the number of terms. Well, there were 50 terms, and I'm going to divide that by 2. That will tell me the number of pairs. So simplifying, I have 151 times 25. And in my calculator, I can see that this is 3,775. The biggest issue here is when you do this in your calculator, you need to add these first. These parentheses matter. So for classwork today, we're going to take a look at all kinds of problems that are sum of series, make use of the formulas, and make use of your notes here.